Have you ever asked ChatGPT the exact same question a few times and gotten slightly different answers every time? One answer might be really direct and predictable. Another one might sound more creative. And then sometimes it gives you something that makes you think, okay, where did that come from? One of the settings that can affect this behavior is called temperature. You've probably seen it in the API settings of different AI models. Maybe temperature is set to 0, 0.5, 1, or sometimes even higher. But what does that number actually do? Does a higher temperature make the model smarter? Does a lower temperature make its answers more accurate? And why is it even called temperature? Let's break it down from the beginning in a really simple way. Imagine we give a language model this sentence. Today, the weather is really... Now, the model has to predict what comes next. It might have a few different options: hot, nice, cold, or maybe even strange. The model gives each possible next word a probability. For example, it might decide hot has a 50% chance, nice has a 30% chance, cold has a 15% chance, and strange only has a 5% chance. Now, here's the question. Should the model always choose the word with the highest probability? Should it always pick hot? Or should it sometimes be allowed to choose one of the less likely options? That's where temperature comes in. Temperature basically controls how conservative or adventurous the model is when it chooses the next word. A low temperature is like telling the model, don't take too many risks. Pick the option you're most confident about. A high temperature is more like, you've got more freedom. Feel free to consider some less obvious choices too. But before we go deeper, we need to quickly understand how a language model generates text in the first place. When you ask ChatGPT a question, the model usually doesn't prepare the entire answer all at once. It generates the answer step by step. First, it chooses one token. Then, based on everything it has written so far, it chooses the next token, then the next one, and it keeps doing this until the answer is complete. A token isn't always a full word. It can be a word, part of a word, a number, or even punctuation. For example, imagine we give the model this sentence. The Eiffel Tower is located in... The model has a huge number of possible next tokens. Paris, London, Tehran, Tokyo, or even something completely unrelated. But obviously, Paris should have a much higher probability than the other options. The model first creates a set of raw scores for all possible tokens. These raw scores are called Logits. You don't need to worry too much about the name. Just think of a logit as a score showing how suitable each token seems to the model. Then those scores go through a function called Softmax. Softmax turns those raw scores into probabilities, so the model might end up with something like Paris 95%, London 2%, Tehran 1%, and the remaining options get very small probabilities. Temperature comes in right before this step and changes the shape of those probabilities. Let's start with a low temperature. Imagine the model has 3 possible choices. Option 1 has a 50% chance, option 2 has a 30% chance, and option 3 has a 20% chance. When we lower the temperature, the difference between those options becomes larger. The option that was already ahead becomes even more dominant. So the same distribution might turn into something like option 1, 80%, option 2, 15%, and option 3, 5%. The model is basically saying, option 1 already looks like the safest choice, so I'll probably stick with that. As a result, the model becomes more predictable. It takes fewer risks. It is less likely to choose unusual words. And if you run the same prompt several times, the answers are more likely to look similar. That's why a low temperature is often useful when consistency matters. For example, when you want the model to generate JSON, extract specific information from a document, classify some text, create a precise summary, or answer questions based on a fixed source. A lower temperature can also be useful for coding because it reduces the chance of the model randomly choosing a weird or unusual solution. But there's a really important point here. A low temperature does not mean the model will definitely be correct. It only means the model is more likely to choose the answer it considers most probable, and that answer can still be wrong. So, lowering temperature doesn't make the model more knowledgeable or more intelligent. It just makes its behavior more predictable. Now, let's talk about high temperature. When we increase temperature, the differences between the probabilities become smaller. The top option may still be the most likely one, but it doesn't dominate as much. So this distribution, 50%, 30%, 20%, might become something like 38%, 33%, and 29%. Now, all three choices have a fairly realistic chance of being selected. The model no longer feels forced to always choose the safest option. It can explore different possibilities. What happens next? The responses become more varied. The wording can become more creative, and if you run the same prompt multiple times, you'll probably get more different answers. For example, let's ask the model, give me 10 ideas for a YouTube channel about artificial intelligence. With a low temperature, it might give you very common ideas. AI tool tutorials, AI news, model reviews, prompt engineering tips. These ideas aren't bad, they're just very predictable. If we increase the temperature a little, the model might suggest more unusual ideas. For example, putting different AI models into a competition, recreating historical events using AI, building games with language models, or testing AI models in strange and unexpected situations. So, for brainstorming, storytelling, writing headlines, advertising, or anything where variety matters, a higher temperature can be useful. But problems start when temperature gets too high. At that point, even weak and unlikely options get a real chance of being selected. Sentences may become strange, the model might drift away from the main topic, different parts of the answer might contradict each other, or it might produce something that sounds creative on the surface but doesn't actually make much sense. So, a higher temperature does not always mean a better answer. It simply means more variety and more risk. Now, you might be wondering, what does a temperature of 0 mean? Because mathematically, if we divide the model scores by temperature, we can't divide by 0. That's true. So, different services usually handle temperature 0 as a special case. In this mode, the model typically chooses the token with the highest probability every single time. This is called greedy decoding. At each step, the model basically asks which token is the most likely right now, and then it picks that token. For example, the capital of France is... The model sees that Paris has the highest probability, so it chooses Paris. Then it does the same thing again for the next token, and it keeps going like that until the answer is finished. A temperature of 0 usually makes responses more stable, but even then, it doesn't always guarantee that you'll get the exact same answer every single time. The model may have been updated. The service infrastructure may have changed. Two tokens may have almost identical scores, or the computation may run slightly differently on different hardware. So temperature 0 usually means more predictable output, not necessarily perfectly identical output. Another common mistake is thinking that a higher temperature makes the model think more intelligently. It doesn't. Temperature doesn't add any new knowledge to the model. It doesn't increase its reasoning ability. It doesn't increase its memory. It only changes how the model chooses between different possible outputs. Imagine the model has several possible paths for solving a problem. With a low temperature, it will probably choose the path it has seen most often and considers the safest. With a higher temperature, it may also try some less likely paths.
Sometimes one of those paths can lead to a really creative or interesting result, but sometimes it can lead to a completely wrong answer. So a higher temperature does not make the model smarter, it just makes its choices more varied. Another thing to understand is that temperature doesn't affect every question in the same way. For example, if you ask, "What is 2 plus 2?" in almost any reasonable temperature setting, 4 is so much more likely than every other answer that you probably won't notice much difference. But if you ask, "Write an interesting opening for a story about a lonely robot," now there are hundreds of possible good answers. In a question like this, changing temperature has a much more noticeable effect. So the more open-ended and creative the task is, the more visible the effect of temperature becomes. The more specific and factual the answer is, the less noticeable it may be.
Now, there's another setting you'll often see next to temperature called top P. These two settings seem similar because they both affect how the next token is selected, but they work differently. Temperature changes the overall shape of the probability distribution. It makes some options more dominant or makes the probabilities more balanced. Top P, on the other hand, controls which options the model is even allowed to choose from. Imagine the model has 1,000 possible next tokens. We sort them from the highest probability to the lowest probability. If top P is set to 0.9, the model keeps only the smallest group of tokens whose probabilities add up to 90%. Every other token is removed from consideration. So even if temperature is high, the model still cannot choose a token that falls outside the top P range. The simple way to remember it is this. Temperature changes the shape of the probabilities. Top P limits the set of available choices. Usually, it's better to adjust one of these settings while leaving the other close to its default value, because if you heavily change both of them at the same time, it becomes harder to understand which setting is causing the change in the output. So, what temperature should you use? The truth is, there is no single perfect number for every model and every task. A temperature of 0.7 may behave differently across different models, but as a general starting point, we can think about it like this. If you want precise, stable, and structured output, a range from 0 to around 0.3 can work well. For example, extracting data, generating JSON, answering from a document, writing a precise summary, or doing tasks where you don't want the model to be very creative. For normal conversation, explanations, or educational content, a middle range like 0.4 to 0.7 is often reasonable. For brainstorming, headlines, storytelling, and generating a wide variety of ideas, you might use something around 0.7 to 1. Very high values can also be used, but usually only when you intentionally want experimental, unusual, or unpredictable output. The best way to understand it is to test the same prompt with different temperature values. For example, run the same prompt once with 0.1, then with 0.5, then with 1. Put the answers next to each other. You'll usually see the model move from a safe and direct answer toward more varied and unexpected responses. Let's look at a practical example. We asked the model, write a slogan for a time management app. With a low temperature, it might say, manage your time better. That's clear, it's direct, it works.
But it isn't very unique. With a medium temperature, it might say, turn every minute into a step forward. That's a little more creative, but it still clearly connects to the product. With a higher temperature, it might say, tame time before your day disappears. That one is more dramatic and more unusual. It might be perfect for one brand, and way too much for another brand. So we can't say that one answer is always better. It depends on what you're trying to do. If the output is going directly into a database, consistency matters more. If you're brainstorming ideas for an advertising campaign, variety may be more valuable. One of the biggest misconceptions about temperature is that setting it to 0 will stop hallucinations. It won't.
A model can still confidently give you a false answer at temperature 0 because the wrong answer may still be the most probable answer according to the model. To reduce hallucinations, you need other methods too. For example, you can give the model reliable information inside the prompt. Use RAG. Limit the model to answering from a specific document. Use external tools. Ask for sources. Or validate the output afterward. Temperature only changes how the model selects words. It is not a truth button. So let's quickly wrap everything up. A language model gives different possible next tokens different probabilities. Temperature changes how close together or far apart those probabilities are. A low temperature makes the model stick more closely to the most likely options. The answers become more stable and predictable. A high temperature gives lower probability options a better chance. The answers become more varied and creative, but the risk of mistakes and irrelevant output also increases. A temperature of 0 usually means the model chooses the most likely token at every step, but even then, perfectly identical output is not always guaranteed. And most importantly, temperature does not make the model smarter or less intelligent. It only controls how conservative or adventurous the model is when choosing the next token. So the next time you see temperature in a model settings, don't think of it as just a creativity slider. It's actually changing the probability distribution behind every word the model generates. On one side, you have safe and predictable answers. On the other side, you have more varied and unexpected answers. And which side is better completely depends on what you want the model to do.